So again, hormonal and look at the endocrine system will have a massive bearing on the epigenome as well.
Absolutely. So there are 4 factors, right, which is contributing to the expression of genes: DNA methylation, histone acetylation, deacetylation, and DNA demethylation. Only these 4 factors contribute to the expression of genes, or are there other factors or pathways which are contributing to this expression of genes as such?
Yeah, no, I mean, there'll be other contracting. I mean, Chris Collins will probably be able to highlight that a little bit more in more detail than what I can.
All right, sure. No problem. Chris, if you can pitch on that.
Yeah, sure. So as a company, we only look at CG site methylation as a way of looking at the epigenome.
Okay.
Before you mentioned histone modification, which is also true as another way of epigenetic change can occur.
Right.
So the 4 areas that you mentioned are basically epigenetic ways of measuring epigenetics, in essence, basically, yeah. So gene expression, though, always starts from DNA.
All right.
So as you were talking how epigenetics is changeable and that can change gene expression. If the gene's already mutated and doesn't work, no matter what you do, it's not going to change that gene's expression. Does that make sense? So if that gene is mutated and doesn't work full stop, you can't do anything to alter that expression. The expression doesn't exist.
Okay.
That's why you can't cure genetic diseases very easily, because it's already embedded, yeah? You can't do anything to do with it. So when it comes to expression, the first area to look at is that gene mutated or not?
Okay.
And then you look at the epigenome after that.
Okay.
Yeah. So when it comes to expression, the areas that you look at are gene mutation, and then you look at what we look at is methylation, CG site methylation. The reason for that is that CG site methylation is the most prevalent across the genome, okay? Whereas the other types of epigenetics are less prevalent, and therefore the effect of those may be limited.
Okay. So say consider, I mean, when we do a DNA test, we get a baseline of the, a genetic blueprint or a fingerprint, what their baseline performance can be, at the genetic level. So if at all they push their body themselves, for, the marker for muscle power is something like such as ACE gene marker, and we have PPAR alpha as well. So if they continuously push their bodies, in spite their DNA reports showing that their muscle power or anaerobic power is something like normal, not naturally gifted. But if they continue to train harder and harder, push their bodies, is it possible for them to adapt to get that gene or make that marker excel towards the anaerobic or muscle power performance? Is it possible to enhance the expression of the gene through training and training?
It depends completely on the level of sport and the type of mutations that we're talking about. So you may have heard of Eddie Hall. He was the world's strongest man in 2017.
Yep.
He got ACTN3 TT. So that would be the mutated variant, which isn't related to power. And obviously he won the world's strongest man. So if you look at it as an example perspective, if you just looked at ACTN3, you would say he couldn't be the world's strongest man because he's got a mutation in there, right? But through training and adaptation, he benefited. But also he's got other gene variants which are linked to power, right? So you can't just look at one gene. You have to look at loads. So we look at multiple genes, and that's called polygenics. Now, when I say it depends what level we're talking about, I would say that anyone who hasn't got some sort of disability or genetic deficiencies or genetic disease, they would be able to get to a good level regardless. Yeah. So if they trained hard, there's a good chance they'll get to a good level. And that good level might be a national level. It might be a county level, and it depends on the sport, right? But when at the beginning you spoke about 100 meters, every single person on that lineup has trained to their maximum level. Every single person has trained their hardest. Every single person's got the best coaches, the best nutrition. Everything's the best. Somebody always wins, yeah?
Yep.
And
so
that's
what do you think that differentiates between the first and the last 100 meters?
Yeah, so I mean, there's no reason why if you train really hard, you can't get to the playing field. But will you be the best ever? Number one, That's the differentiating factor between actually this person is just a little bit too gifted. And even people who cheat or people who in sports where steroids and drugs don't matter, it's actually genetic as well, because your response to a drug is genetic. So your response to an anabolic steroid is genetic. So in sports where steroids are allowed, like bodybuilding, for example, it's actually the person who responds best to the steroid who gets the best results. So even on that level, you can't beat genetics. So at the end of the day, the DNA is always going to be there. It's always going to be important. You can certainly train and get to a good level no matter what. But the idea is that you can tweak your training based on. So whether or not you need to rest a bit more, whether or not you need to concentrate on power or endurance, maybe the sport's wrong for you. So maybe you are trying to be a 100-meter sprinter, but actually should be a 1,500-meter runner or a marathon runner, right? So that's where the DNA comes in and might put you in a better category.
All right. So it sets you to the, fixes a direction for you to go, basically. So that's the way DNA works and sets you the baseline in order to recommend you for the, taking a correct path, as I could put up those words, maybe.
Yeah, so you can have, like, for me, I wouldn't want to say to someone you should do and be a marathon runner if you want to be a sprinter. But if, say, they're playing football or soccer, and it could actually help them pick a position or how to play the game, right? So maybe in the case of you should actually be really quick. So we're going to concentrate on your speed, because that's going to be the advantageous factor for you. The advantageous factor for your partner, though, he's VO2 max, is going to have a higher ceiling. He's going to be better at endurance. He's going to be able to last 90 minutes plus and run up and down the field. He should be central mid. You should be right back, or maybe you should be a striker. And you can actually pick positional play without changing the sport totally. And it brings out your gifts. It allows you to excel in the areas that the DNA is basically telling you that you should be able to excel in.
Okay, right.